Hi, I'm Dr. Jason J. Campbell, and I want to thank you for taking the time to watch my videos. In this video, I'm going to be doing a discussion on modal logic. I've had a lot of requests from viewers from all over the world asking me if I go into a little bit more detail on modal logic, and after getting the request, I decided to look on YouTube to see if there were any good videos on modal logic. I hadn't seen any videos on modal logic. Furthermore, some of the videos that I did see on modal logic confused some of the systems and the axioms inherent in a discussion of sort of higher order mathematical logic. And what I wanted to do is to actually do two things. First of all, my intention is to make the information accessible. I don't want it to be the case that people look at the symbols for modal logic and think, oh, it's something I can't do. I definitely want to educate you all on the sort of the nature of modal logic to make it more accessible. The next thing that I want to do, the next purpose I have, is to show you that modal logic has applications to social scientists, right? I'm a social scientist. I'm not a scientist proper. I don't do hard science. And people believe that sort of logic and mathematical logic is only for people who are in like engineering or physicists and so on. You can use modal logic in an analysis of language and an analysis of argument. I use it specifically solely for analyzing argument. There are many applications of modal logic, and I'll sort of see how the videos, sort of the responses I get from the videos, to determine whether or not I'll go into more structures of modal logic, like deontic logic and so on. Deontic being sort of like an obligation-based, something that you have to do, you must do, you're obligated to do, and so on and so forth. So basically all I want to do now is a very sort of general, very accessible introduction to modal logic. It'll clear up a lot of the confusion as to how modal logic functions and the role that it has, and hopefully it'll make it accessible and inviting to all of the viewers. With that being said, I'm going to begin. Alright, so this is an intro to modal logic. Alright, so the first thing that I want to do in discussing modal logic is I want to clarify some of the confusion about the symbols, right? Because you look at a math text or a logic text, more properly, a logic text, and you see all of these symbols and you think, I don't understand what that means. What I want to do is define the symbols, tell you what the symbols mean, string the symbols in a statement, a judgment, and then we can read through, I'll read through the symbols so that you'll have an understanding of how it's read, how the symbols are read as expressed. And then we'll look at the application of modal truths to, you know, as far as I'm concerned, to argument in the language. And as I said, I'm going to try and make this as simple and as user-friendly as possible. Alright, so let's begin with the symbols. The first symbol is a diamond. And when you see a diamond, all the diamond really means is the following, is that it is possible that, so anytime you see the diamond, it just means it is possible that, and it's possible, which is important, it is possible that some state of affairs might happen. So it might be something like, it is possible that this Friday I will go out to have something to eat. Right? So that's a statement that I might make. And again, as I said, I use this for the analysis of argument, right? So I might make the claim that it is possible that this Friday I'll go out and get something to eat. I could represent that statement, it is possible that this Friday I might get something to eat, in terms of using this diamond. So I mean, that's pretty basic. The next is the square, right? Anytime you see the square, it means it is necessary that. Right. So in modal logic, this is what I'm specifically using, right? I'm using both of these claims, right? I'm going to look at this operator. I'm going to look at this operator. This operator tells me that it is possible this operator tells me that it's necessary, whatever it is that I'm looking at. It is necessary that XYZ might be the case. Okay. Well, some of the symbols that we've used in symbolic logic, right? Some of the symbols that we've used in symbolic logic, which we'll also use in modal logic, I've said in my videos on my 10-part video on symbolic logic, like an intro to symbolic logic. So a lot of this is just a quick review. I'm not going to get into it too much. The first is an arrow. Some people use different symbols. I use an arrow, and this is if something happens, then something else will happen, right? So if something happens, then something else will happen. I use a black dot to mean a conjunction, which is and. The next thing is the tilde. I use that to mean not or negation. And then the last thing is the double-sided arrow, which is known as a biconditional. And this is if and only if, right? So these are the symbols that we'll be using, right? So, for example, we've used this before to say something like, if P happens, then Q will happen, right? And so on and so on. So, what we're going to look at specifically today is the sort of the merger between some of the symbols that we've already been introduced to in my lectures on symbolic logic, and then incorporating these symbols of symbolic logic with these two new operators, these two new symbols from modal logic. And then we'll talk about how we can make sense of both necessity and possibility, right? Something is possible, something is necessary, and we'll begin in that sort of mode of analysis. Okay, so hopefully that's clear.